Okay, so we're looking at problem 9 here, and we've got a circuit. It's got some series parts and some parallel parts. And I thought about it this way. I thought about the circuit because it was kind of confusing because I had the battery and a resistor on the same line. So I had to kind of follow the path around from the positive terminal, that right-hand terminal over here, okay, all the way around. So I started there, and I said, okay, so let's start there. So I got a battery. And I said, so after that, it kind of splits into 3 paths, okay, to get back. Okay. One of those paths, so I'm going to have 1, 2, 3 paths. One of those paths is that 10 ohm resistor, the one on the bottom here, this one. Okay. That's this one, the 10 ohm resistor on the bottom. Okay. Another path is going to go to these two. Okay, I'm going to put that one on the bottom. That's the 20 and the 5. And then there's a path right here, and that's the 5 that goes there. And if it goes back through all of those, then it's got to go to that other 10 ohm resistor. So that made it a little clearer for me, because then I knew, okay, so I have 3 parallel paths with one that's always in series and one path that has 2 series with each other. Okay. So that actually made it easier for me to reduce. So I started to try to reduce it. So first, I combined these. These are 25 ohms. Okay. And then I was able to find the resistance of the whole circuit, because I wanted to find out what the equivalent resistance is and then work backwards. So I said, okay, well, let's start with all the parallel ones. So if I find 1 over the total, the equivalent resistance, that's going to be 1 over 10 plus 1 over 5 plus 1 over 25. Okay, and that's going to leave my equivalent resistance just of that little section there. It's going to leave me with, I'm going to add them together, the fractions, and then I'm going to take the inverse of all that, and I'm going to get an answer of about 2.94. And that's just this stuff here. Okay, so that's this. So then to get the total, get the real, so I should just call this like R parallel or something like that. Probably be better. So, but then to get the equivalent resistance of the whole thing, I just have to add that 10 to it because it's in series. So it's going to be 12.94 ohms for the whole thing. Then I can find the current, like the total current in the circuit. I'm just going to take that 25 volts and I'm going to divide it by 12.94, and that gives me 1.93 amps. And that's actually the current that's going this way through here, 1.93. But that current's going to split 3 ways when it gets to here. Okay. So how do I figure out how much current that's going to get? Well, I have some help there, because I know that whatever voltage it's going to get is going to be the 25 from the battery minus whatever voltage this is, because we know that it's a series element. So the voltage for all the parallels is going to be the 25 volts from the battery minus the current in the battery, which is 1.9, or sorry, current in that top resistor, times the resistance of that top resistor, the one that is in series, the one that has to go through. So it's like 19.3. I got a voltage of 5.7 volts for that. Okay. That ends up being really useful to me, because that's the voltage that this that the resistor here gets, that the resistor here gets, and that these two resistors get together. Okay, that's going to help us a bunch because now we can find that out. So I know that the resistor, so now I can use Ohm's law to find the rest. So I know the total resistance is going to be 25 ohms. And remember, I have to use the total resistance because they're in series. I know the voltage across both of them together is 5.7 volts. I divide the two, and I can find the current just across that little branch. It's going to be 5.7 divided by 25. I got an answer about 0.228 or 0.23 amps. Part B asks about the potential difference between points A and B. Whoops. Potential difference between points A and B. But that actually turns out to be an easy thing. Remember, we found that. That was the potential difference between those. Okay. We found that it was going to be the same as the battery voltage minus the current across the whole circuit times that 10 ohms for this thing up here. And that's going to give us 5.7 volts. Remember, that's going to be the same amount that the bottom 10 ohm resistor in parallel and this one gets. They're all going to get the same number of volts. That's going to be the potential difference across A and B.